Hey gang, this is going to be a quick little intro on a program called Plotly. It's analyzing and visualizing data. Make a free account. You can use it for free without the account, but this allows you to save some things. I'm already logged in here. And we're just going to go to a new project. I'm going to start with a data table. Let's start with a super simple data table. As soon as it loads. This one's going to be 0, 0, 1, and this would be, you're taking data in a lab, and this is where you type it in. You can probably already guess what this function is going to be, and that's fine, because we want to know the outcome so you can see how this works. Alright, that's enough data. And now I want to make a plot. I want to make a scatter plot. If this window wasn't already up, it would bring up this window, and I'm going to click scatter plot. Don't worry about any of these things for now. And you can play around with all the millions of features. And there's the plot. We see it going up like that, just like we would have expected. And the most important thing we want to do with this data is find a relationship between the two variables. Remember, don't forget to always label your axes with both a label, distance, and a unit, meters. Now, we're just making this data up, so this doesn't necessarily correspond to anything we're actually going to do in the lab. But let's fit the data. We want to find the relationship, the equation that describes the relationship between those two variables. So we're going to add a fit to this trace. And you can choose from a whole library, but I'm going to show you define your own function. Most of the time we're dealing with power graphs. It's y equals x to some power. So I'm going to guess x squared. And I'm going to run this fit. And bang, it matches up exactly with our data. It gives us an r squared value of 1.00. That means it went through every single data point. I'd like to add that result as a plot annotation, and we see it here. That's pretty much it for the fit. If you messed up, you can go back and edit the fit. Let's suppose you tried x cubed first. You would see that that curves too much. Maybe you tried x to the first. Oh, that's a linear graph anyway. Maybe you tried x to the 1.5. Remember, whole and half powers here only. That you never guess 1.25, 1.37. It's 1.52, 2.53, and you can go negative. Yep, that didn't work. Okay, so we're convinced this is x squared. All right, let's close that window. We don't need that anymore. And one thing we want to do here is edit x and y. Those are meaningless variables to us in physics. What's on the y-axis is distance. So I'm going to write d for distance. What's on the x-axis? I'm going to get rid of that x. T, time. And then I can just click anywhere, and that does it. Go ahead and leave the r squared value there. Don't forget a title. It's always y versus x. And you don't need the units up here, just y versus x. And that would pretty much be it. You can print that one out. Done with that.